Hello everybody, in this video we are going to continue our conversation of how to simplify radicals and radical expressions. So in some of the previous videos we have already talked about what a perfect square is, how square roots undo those perfect squares. We made a list of perfect squares up to 15 that we're using to help us break down these square roots. We've also looked at several examples on how to take a number that isn't already a perfect square and using perfect squares from that list that we created, how we can break them down and simplify these square roots. Now we looked at the examples that have no numbers on the outside, and then we looked at what would happen if we did have a coefficient or a number on the outside of the square root, how we would wait till the very end to multiply it. To simplify it further. But we do have some square roots that would be considered our special square roots, because even though they don't come up that often, when they do, we need to be prepared on how we're going to answer. So one of the first things that I mentioned when we were working the other kinds of problems is make sure that the number underneath the square root isn't already a perfect square. Because if it's already a perfect square, we don't have to do all of this work to simplify it. So let's look at the first example that we're going to look at right here, which is 64. We have the square root of 64. So we need to see if 64 is already a perfect square. So number one, you can go back to the list that we created at the beginning to see if 64 is on here. If it is, then we just have to figure out what number times itself would give us 64, and then we're done. But if you don't want to look through the list and you want to get to your answer a little bit quicker to know if something's a perfect square or not, then you can easily grab your calculator and type it in there. So if I grab my calculator here and I take the square root, so do square root, type in 64, and you hit enter, notice that it doesn't give me a decimal, because that lets me know that 64 is a perfect square and the square root of 64 is 8. So let me give you an example of a number that is not a perfect square so you can see the difference. So if I take the square root of the 27, the very first problem and number that we looked at, if I take this and hit enter, it's going to give me 5 all these numbers. So notice it doesn't give me a whole number, so that automatically tells me 27 is not a perfect square. I do have to do the work to break it down to simplify it. But since that first one that we did gave me 8, we're done. So when you're working these problems, it's really important that you ask yourself, is this already a perfect square? If it is, then write down the number. If it's not, then go through the steps of looking for the factors, finding the biggest perfect square, and then breaking it down. So that's it. That's it. That's what makes this one special, is it does catch us off guard from time to time. All right, we're looking at this one right here. And one of the things you're going to point out, if you type in a negative, every single example that we've done so far have all been positive numbers. So what happens when we take the square root of a negative 16? What is that going to do? So before we look at that and type that into our calculator, one of the things that I do want to point out here, perfect squares are always going to be positive, because a positive times a positive would give you a positive number. And if you multiply a negative times a negative, it will still give you a positive number. So when we're dealing with square roots, we won't have any negative numbers underneath the radical. So if you see a negative, you can automatically say this is a no solution, because there doesn't exist a number times itself that would give us a negative number. But if you forget that, you can always type it into your calculator, just like I asked you to do. We know 16 is a perfect square, but what happens when it's a negative? So a negative 16. And so if you hit enter here, you would expect to see a negative 4, but not really, because this number does not exist. They actually consider it an imaginary number, but we're not ready to talk about imaginary numbers in Algebra 1. So in this case, the only thing we have to do is say no solution. This number does not exist. So do not be tempted to write -4 here because that is not the case. So we're just going to write no solution because of this negative. So no negative numbers underneath the radical. All right, let's talk about 70. So if I type in 70, the square root of 70 in my calculator, the square root of 70. You're going to realize it's not a perfect square. 70 is not on that list. I type it in my calculator. It doesn't give me a whole number. I'm going to have to break this down. So what I'm going to ask you to do is go through the steps. We're going to start this just like we do any other number. We're going to say 70 and then break it down to 1 times 70, 2 and 35, and then 70 divided by 3 doesn't go in. 70 divided by 4 does not go in. 70 divided by 5, 14. And so we're going to go through this and try to figure out all the numbers that divide into 70. So 70 divided by 6 does not exist, but I know 70 divided by 7 is 10. 70 divided by 8, nope. 70 divided by 9 doesn't exist. 70 divided by 10 does, but that is already on this list. So because we already have it, we can stop here. Now, one of the things that you're going to notice, and it's really important that you know your perfect squares. That's why we created a list of perfect squares. You're going to notice that none of these numbers are on the list. They are not perfect squares. So go through there and you're going to notice that 2's not on there, 5's not on there, 7's not on there, 10's not on there, 14, 35, 70. None of these numbers are perfect squares. We cannot write this like this unless one of the numbers is a perfect square. So for that reason, the square root of 70 is as simple as it's going to get. It cannot get simpler than this. So the answer is the square root of 70 because it can't be broken down. And sometimes we have a hard time seeing that because we're used to these numbers being big. We're used to finding two numbers that divide and can be simplified. But 70 is just one of those numbers that cannot be broken down any further. So I'm going to say it again. We cannot break down these numbers unless one of the numbers is a perfect square. So I'm going to remind you what we did in the previous problems. We were able to use 9 and 3 for 27 because 9 is a perfect square. We were able to use 16 and 6 because 16 is a perfect square. 64 is a perfect square. 36, 16, 9. We can't do this unless one of those numbers is a perfect square. And in this case, none of these are. That's why it can't be broken down. All right, with that being said, I'm actually going to stop right here. We're going to go to the back and we're going to have a conversation in the next video about like terms. Now, we already talked about like terms before, but we're going to look at some different like terms that we might not be as familiar with. So I hope that these examples have helped you understand how to break down a square root, how to simplify a square root, but I will see you in the next video.